Hello, today I'm going to go over oxidation number calculation practice. Oxidation numbers, and it talks about that here a little bit. Oxidation numbers are used to kind of track the movement of electrons and also understand the charge on either molecules or specific atoms. When we start to look at oxidation numbers within molecules and atoms, we have a set of guidelines or rules, and I have a set here that you can use for this activity. These will help you figure out the oxidation numbers for our examples down here. So I'm going to go over some of these and do some examples. The first rule or guideline says element by itself, the oxidation number is 0. And what we mean by the element by itself, well, here's an example of that. Cl, which is chlorine, and there's 2 of them. So if there was 1, it would still be the same, 2, 3, however many there are. If it's just chlorine, just that one element, and it's bound to itself or by itself, its oxidation number is 0. So I just put a 0 up there. That's where I'm going to have my oxidation numbers. And then it talks about some other things like group 1A is always is important. Group 1A is always +1 for an oxidation number. And they're referring to these here. Note that hydrogen is going to be a little different. And we do have some rules for hydrogen over here. And then 2A is always 2. So we got 2A here. Halogens are this group right there, starting with fluorine and chlorine. And monoatomic ions. So ions are when they have either a plus or a minus charge. You'll notice that the element by itself did not have a plus or minus charge. But when it does have a plus or minus charge, like potassium here, yes, it's by itself, but it's an ion because it has a +1 charge. In this case, your oxidation number is whatever the charge is on that specific element. So in this case, we have a +1 charge. That means the oxidation number is +1. We also have some rules over here for hydrogen, oxygen, and fluorine. Let's do another example. Let's look at this one here. KCl, so potassium and chlorine. Now, it tells you the sum of oxidation numbers for a neutral compound. So this is a compound. It's neutral because it has no charge. The sum of the oxidation numbers is going to equal 0. So I'll show you what that's going to look like. I have 2 things. I have my potassium, which I know is a +1, and I have chlorine over here, which according to my halogens is usually -1. But I know the potassium is always going to be +1. So let's start with that. So I know right off the bat that my oxidation number for potassium is +1. I also know that whatever it is for chlorine, when I add it to this +1, it's going to come out to 0. So it does follow our rule here. Chlorine is going to be -1. Because when I put +1 together with -1, I get a 0. That's this sentence down here. So those are my 2 oxidation numbers, +1 over potassium, -1 over chlorine. Let's do another one. We'll do this one down here. And I've got nitrogen, which is not really part of our rules. Nitrogen's down there. And I've got oxygen, which oxygen is in our rules. So let's figure out oxygen first. Usually -2 unless it's in a peroxide, H2O2. So that's not the case for us. So it's going to be -2. But you have to understand that there's 2 oxygens. The whole molecule has a -1 charge, but there's 2 oxygens. So I have 2 -2 charges. So -2 times 2, my oxidation number here is going to be -4. I know that the oxidation numbers of the nitrogen and oxygens are going to equal the charge, which is -1. So what number plus -4 equals -1? +3. So +3 and -4 equals -1. And I got that -1 from here, right? All right, let's try another one. We're going to try this one down here. I have bromine, which is another halogen. My halogens usually are -1 unless it's bound with oxygen. So you'll see that oxygen's present. So it looks like our halogen is probably going to be a positive number. So I'm not sure on that, but I do know that my oxygen is -2. How many do I have? I have 3 of them. So times 3. That makes it -6. The overall charge on this molecule is -1. So I know these two oxidation numbers added together will be -1. What number can I put in here that makes -6 equal to -1? A +5. +5 minus 6 equals -1. So those are my two oxidation numbers, +5 and -6. All right, you're going to do the same thing for the rest of these, same as the examples that I just went through, using the rules. Make sure you look at where it says always, usually. Look for the exceptions, like hydrogen. Know whether it's bound to a non-metal or to a metal, because that's going to change the oxidation number. Okay, ask me if you have any questions. Thanks.